Hello and good day, geometry. I am with you talking about CO18, continuing our unit, which is essentially on angles. And we started in PO17 with the triangle sum theorem, the exterior angle theorem, talking about those relationships within triangles. Today, I want to introduce to you what is called the transversal. And a transversal is a line that intersects two or more other lines. A transversal is a line that intersects two or more other lines. So looking at these four diagrams that I have here with the four keys here, I'm just going to highlight the transversal in green for you so you can see it. The transversal, this line that is intersecting those other two lines that are going horizontally. Transversals there, transversal here, and transversal here. And I highly recommend that you get some different colors to use for this particular page, or maybe you want to just identify these different angles using shapes. Because why we care about transversals is they create some really interesting angle relationships, particularly when the two lines they intersect are parallel. Here they are not. So today we're not focusing so much on the relationships with parallel lines versus just what the different relationships are called. So more of the what and not so much the how or the why. Today is kind of a what day, okay? So what are corresponding angles? Well, when you've got a transversal that intersects these two other lines, corresponding angles, you can kind of think about it as same location, different vertex. That's our phrase here. Same location, different vertex. Okay? Because, for example, this angle here is that's a really good color job right there. My goodness, I don't think I've ever done that well ever. I'm going to take a screenshot of this. That angle, that kind of upper right section, if you think about, this top intersection point, I don't want to write, but that upper right corner, it's going to correspond, another solid one there, with the upper right location in the second vertex, that second point of intersection. So those two angles would be corresponding angles. Another pair of corresponding angles would be the top left here with the top left at the other intersection. Those would also be corresponding angles. A third pair, the bottom left and the bottom left, those would be corresponding angles. If you ran out of colors or you don't have colors to use, like I said, maybe you want to just use shapes. So if I want to put a little star here in that bottom right and a star here for the bottom right there, those would be corresponding angles as well. So I've got four different sets of corresponding angles here based on their location. Same location of their vertex, top right, top left, bottom right, or whatever, but at the different vertices that are formed here, okay? Alternate interior angles. Alternate interior angles. Well, the word interior means inside, and the word alternate can, in this context, mean opposite. And what we're talking about here, the opposite sides of the transversal on the inside of our two horizontal lines. So the inside of our two horizontal lines, is this area in here, okay, in between them. Alternate sides of our transversal, or opposite sides of our transversal, this angle and this angle would be one pair of alternate interior angles. They're on opposite sides of that transversal, that's in green there, right? And they're both in between on the interior of our horizontal lines, or the lines that are being intersected. The other pair of alternate interior angles, there are only two pairs here, because there are only two angles at each vertex that are inside the lines, would be the angles in black. That would be our second pair of alternate interior angles. The third one here, alternate exterior. The word alternate, we can still think of it as meaning opposite, but now the word exterior means outside, right? Just like we saw with the exterior angle theorem, it was on the outside of the triangle. Now our angles are going to be outside of our lines being intersected. So rather than in between, it's going to be this area out here and that area out there, right? And so alternate exterior angles, one pair would be this one and that one. They're on alternate sides of the transversal on the exterior, the outside of the two lines being intersected. And a second pair would be in black here, this one and that one. Also alternate exterior angles. Okay. The last one here, consecutive interior angles. Again, that word interior, meaning inside. And consecutive means next to. Okay. Now, I'm going to start by showing you what are not consecutive interior angles. This would be an example of angles that are not consecutive interior. And you might say, well, yeah, but they're inside the two horizontal lines and they're next to each other, so that fits the definition, right? Next to and inside. Why aren't they? The reason why they are not consecutive interior angles is because they're at the same vertex, right? They're not using that upper line at all, okay? And you need two lines being intersected in order to create these relationships. So if you're looking at consecutive interior angles at just one vertex, you're doing it wrong, right? No other way to say it. So when you retrace our transversal here, an example of angles that would be consecutive interior, right there. Okay, two vertices, right? They're next to each other in the sense that they're on the same side of the transversal. There's one up above the other, and they're inside our two horizontal lines. Another pair of consecutive interior angles, and there are only two of them, would be here in black and there in black. Right? So very similar to the alternate interior angles, because both are inside there. But notice that our pair of angles, our red angles here, are on opposite sides of the transversal. The black ones are on opposite sides. Here, our red are on the same side, and black is on the same side. So that's the difference between alternate interior and consecutive. Okay, but there you have the four names of the angle relationships that exist when you have a transversal. So the bottom part of this page is going to be identifying them in diagrams. It says in each diagram below, identify the transversal or transversals, could be more than one, and label one pair of corresponding angles. I'm going to label my corresponding angles in red. Alternate interior angles, I'll do that in green. Alternate exterior angles, I'll do that in blue. And consecutive interior angles, I'll do that in black. And I'll also identify my transversal in black as well. Okay. So this first one, I'm going to not do that one because it looks very similar to the ones we have up have up above. I'm sure you're looking at some of these other ones saying, what in the world is going on here? So let's look at the third one here, the one right below it. Kind of funky, okay? But our transversal is the line that intersects the other two. And if you're thinking to yourself, well, this one's going to extend and it's going to cross that line as well. That's kind of what we have going on in the fourth example here. That would be another transversal, but the diagram as it's labeled doesn't show it, even though it will. So the transversal that we're looking at is just this one here, right? This vertical line will extend downward, but it doesn't in the diagram, so we can't identify any relationships that exist in the diagram. So we're going to use the one that we have there. So transversal, the one that intersects the other two lines, there we have it. Okay, so let's start with corresponding angles. I will label one angle, and we'll see if you can label its corresponding angle. Okay. So it's kind of difficult here because if you're thinking about, what's interior and what's exterior, the interior, and this might help you here, the interior of these lines would be like this space in here and this space here. It's not really between the lines per se, but it is also in between the lines in the sense that it's the intersection of where this transversal intersects each of them. So when you think about corresponding angles in that same location, different vertex, what is the location of that red angle? Is it inside the lines, outside the lines, left side, right side? Okay. The other corresponding angle, we consider this outside the lines on the right, or the upper right. I shouldn't use the word outside for that. It's upper right location of that vertex. The corresponding angle is going to be right here. Same location, different vertex, that upper right section. For alternate interior angles, I'm going on the interior. There's one. What's the other alternate interior angle to go with that angle in green? Alternate, opposite side of the transversal, in between the lines. It's going to be right here. The other side of the transversal, I'm still inside the lines. Remember we said this is kind of our inside the lines area here. Okay? So alternate interior. Alternate exterior in blue. Do this one. Okay? I'm outside the lines now. This would be our area outside the lines here and down here. Okay? Opposite sides of the transversal. Outside our lines being intersected. The other alternate exterior angle associated with the one in blue is going to be down here. Right? And finally, consecutive interior. I'm going to kind of overlap angles a little bit here. Giving you this one inside the lines on kind of the left side or the top side of that transversal. That is consecutive interior angles. Actually, it's the same angles we had for our alternate interior one here. Both are on the same side of the transversal on the interior inside the lines. Okay, so there you have it. The one on the right here, this last one, you've actually got 3 transversals because they all intersect each other. So by me tracing them in black, it's really just retracing the entire figure. But it does give you a lot of options for corresponding alternate interior and exterior because you got 3 transversals to work with here. For my corresponding angles, if I go, right here and label that as one angle, well, that's the upper right section of that vertex. So its corresponding angle might be the upper right section of that vertex there, or the upper right section of this vertex here. Okay? All three of those red ones would be corresponding angles. They're the same location, different vertex. And when I use the phrases upper right and upper left, and I understand that it gets a little bit tricky when you've got, like we have here, that more X shape, but you're looking at the position of it. As a transversal is coming through this vertex, right? That corresponding angle, that right side, as it's coming through the vertex here, that upper right side, that's what we're calling it. Okay. And actually, whoops, I hate when I make mistakes at the end of the video. So I don't know how to edit, and I don't want to start over. But here, if I'm looking at this transversal going across, as I pass through this one, that angle is kind of on that upper left section. Here, as I'm looking horizontally, so ignore the top part of the diagram. As I come through here, this would be the corresponding angle. Is that the same spot I had it? Maybe I was right. I don't remember. No, I think it was, yeah. So this would be the correct spot, looking at going this way with the transversal, okay? And looking at this way with the transversal here, that would be corresponding angles. So maybe don't label all three corresponding angles, because depending on how you're looking at the diagram, your point of view, those corresponding angles are going to change. So don't label all three of them. Just pick two vertices. If you just want to, since I probably royally confuse you now, and I apologize for that, if you want to ignore like this section of the diagram here and just focus on this transversal intersecting those two lines and just deal with those vertices, great. I actually probably, for how I botched that, would recommend that you look at it there. But if you get it with the other three, then you get it. Anyway, whew, there you go. It's a Friday. That's how you math, folks. There is a quiz on Google Classroom on CO18. Both quizzes for 17 and 18, please have them done by Sunday night so I can kind of look at them Monday and decide what I want to do for lessons. You'll have another recorded, a double feature next week, one Monday, one Tuesday before Thanksgiving break. Just kind of get us caught up again. Those won't be due until we come back on the 30th. So you'll get them Monday, Tuesday, but you'll have all weekend, that long weekend, to work on them. But 17, 18 quizzes, please have them done Sunday. And this is kind of your homework. So if you are doing these quizzes, you're getting checked off as doing the homework. If you're not, then unfortunately you will lose points once we get to the test and have that homework score objective. So transversals, there you have it, folks. Have a great weekend. Email me if you've got questions. You've got Khan Academy out there. Do Thanksgiving night. Get it done now. Do not forget to like and subscribe.